In this video, I'm going to show you how to build a high-performance web infrastructure in Google Cloud. Think of this as a proof of concept, a master template that you can use in real-life scenario or that your company can adopt to ensure their applications stay online and secure. We're going deep into the stack to show you how to build a secure, reliable, redundant system. I'm excited to show you why the cloud is the best place for your business-critical workloads. Now, let's talk about the deployment phases. We'll start by initializing a new project and enabling the necessary API. From there, we build our virtual plumbing, the VPC, and subnets. Then, we'll move into the security phase, configuring our firewall policies and the NVA. Next, we'll deploy our dual Linux web servers, deploy our global load balancer at the edge, finishing with domain integration and public DNS configuration. Finally, I'll perform multiple tests to show you that the traffic is flowing correctly in every aspect. By the way, my name is Anthony De Los Santos. I am a network engineer, CCNP certified, and I hold multi-cloud certifications across AWS, Azure, and Google Cloud. I've designed this lab to show you how these world-class platforms integrate to solve real-world problems. So, let's get started. Presented here is the high-level architectural topology for our Google Cloud environment. In the upcoming segment, we will perform a deep dive into each specific component, examining their strategic roles and technical capabilities and how they collectively fortify our infrastructure. Now, let's discuss the device purpose and capability. Our first component is the load balancer. At the front of our architecture is the Google Global External Application Load Balancer. This, our expert primary shield, positioned at Google's global edge. It absorbs massive DDoS attacks before they reach our network, ensuring stability. Its first critical task is SSL termination, decrypting incoming packets to offload heavy CPU processing from our servers, and providing clear text for deep packet inspection. Beyond security, it serves as our intelligence layer. Through active health checks, it monitors backend responsiveness in real time, using algorithms like round robin to distribute workloads. If a server fails, the load balancer instantly diverts 100% of traffic to healthy instances. This creates a high availability environment with zero downtime, ensuring our digital assets stay fast, secure, and always online. In layman's term, load balancer is our front door or expert receptionist. Next, we have the Network Virtual Appliance Firewall, the core of our security layer. By terminating SSL at the load balancer, we give this firewall appliance the ultimate advantage for clear text visibility. This allows us to perform deep packet inspection. Without the performance lag of decryption, we aren't just looking at the envelope of the packet, we are reading the letter inside to catch threats. This firewall operates at layer 7, provides WAP-level intelligence, it actively identifies and blocks application layer exploits like SQL injection, and cross-site scripting while enforcing strict protocol standards. If an attacker tries to tunnel unauthorized traffic through an open web port, the NVA kills the connection instantly. Then it's implemented east-west segmentation. Because the firewall sits between our subnets, it prevents lateral movement. If one server is compromised, the threat is contained, and the rest of your infrastructure remains secure. This isn't just a firewall, it's a proactive zero-trust gatekeeper. We can call this in layman's terms as our security guard. Let's talk about the VM servers. This is core value of our backend fleet. These Linux VMs are dedicated to application hosting and dynamic content processing, acting as the engine that actually runs our code, and act as web server. Because they are encapsulated within a private subnet, they can safely manage internal resources and database connectivity without being exposed to the public web. By distributing these tasks across a redundant pair, we achieve service-level redundancy, ensuring that the backend protocols are always active and ready to deliver a seamless experience to our end users. We can say that these VM are our workers, in layman's term. Lastly, in this project, the GoDaddy domain hosting layer functions as the critical gateway between the public internet and our private Google Cloud environment. Its role is twofold: connectivity and trust. I will host also my website here as www.xyz-company.org. GoDaddy will also manage our DNS host records. We ensure that users are accurately routed to our Google front end. It will handle also the SSL certificate management and domain security. This provides the encryption and identity verification that is necessary for modern web standards. By leveraging these tools, we ensure that our infrastructure isn't just reachable, but also professional, secure, and resilient against external identity threats. Let's discuss about detailed traffic flow. To truly appreciate the resilience of this lab, we must go beyond the surface and trace the life of a packet. We are about to perform a deep dive, hop by hop analysis of our traffic flow. This isn't just about connectivity, it's about understanding the why behind every millisecond of processing. We will examine exactly how each device secures, inspect, and routes data to see how transform raw internet traffic into a hardened, high availability service and design. First, let's talk about the DNS part. When the browser requests www.xyz-company.org, it first needs a destination IP, GoDaddy's name. Servers act as the global directory, identifying the A record we created for this project. They then hand off the traffic to the Google Load Balancer's global static IP. Then user's PC now sends a packet to your global load balancer on port 443 HTTPS. Then load balancer presents its Google managed SSL certificate. Then user's browser verifies this with a trusted authority. After that, the load balancer decrypts the packet right here at the edge. Now the traffic is on plain text, but only within Google's secure internal backbone. This decrypting is needed so that the firewall will be able to do the deep packet analysis on next hop. Then the load balancer now looks at its backends. To decide where to send the packet, it uses two main tools by doing health checks. It only picks a server that is healthy. If all servers are healthy, it will decide to send the traffic based on load balancing algorithm. Usually, it uses maglev hashing or round robin. Once the load balancer picks a target, which is our firewall VM, it performs the proxy jump. The load balancer changes the source IP to a Google internal IP, example 130.211.0.0, and for destination IP, it targets the private IP of NIC0 on your firewall, example 10.0.1.1. The packet jumps from the Google Edge network into my VPC, then going to firewall. Then the packet enters the firewall via NIC0. The firewall performs Deep Packet Inspection, DPI. Since the load balancer already decrypted the traffic, the firewall can read the data to see if it contains viruses or hacking attempts. If the packet is safe, the firewall forwards it from NIC0 outside untrusted zone to NIC1 inside/trusted zone. Before we continue to discuss the return traffic, it is essential that you will know how the proxy jumps work in Google Cloud Platform. As you can see on the screen, our global load balancer sits at the very edge of Google's infrastructure, acting as our single entry point via its static public IP. To bridge the gap between Google's global network and our specific VPC, Google Cloud Platform utilizes a proxy subnet mechanism. Think of this as a secure internal bridge. It uses a dedicated Google IP range to jump the traffic from the global edge directly into NIC0 of our firewall. Mastering this connectivity handoff is essential, as it's the secret to how Google maintains high performance, while ensuring the traffic reaches our private environment securely. This concept must be fully understood so that you will not be confused when building a Google Cloud infrastructure when tracing the traffic flow. The return journey is the mirror image, but it must follow the same stateful path. The web server sends the HTML back to the firewall's NIC1. Then firewall passes the data out through NIC0 back toward the Google proxy jump range. Then it will continue to go to load balancer. Then the load balancer will re-encrypt the HTML packet using the SSL certificate. Then sends it across the public internet to the user's browser. That's the whole process on how the packet will flow on this cloud infrastructure. Welcome back, everyone. Today, we're going to get our hands dirty and build out this architecture from scratch. First, we need to create a new project, and here's my topology. We need to go to console.cloud.google.com, click on Create or select a project. Then create project, name it as Tony-Lab-02. Select your billing account and click Create. Once the project is created, select Project. Next, we need to activate the Compute Engine API. Click Enable. Now the Compute API is activated. Next, let's create the VPC. We will also select the region and create the firewall and VM subnet. From search bar, find VPC network, then click Create VPC network. I will name it as Tony VPC, and for description, I will use the same. Now let's create the subnets. First, we will create for firewall subnet, and the region is Middle East Doha, and the IP range is 10.0.1.0/24. Then we need to add another subnet for our VM. Click Add Subnet, and we will name it as VM Subnet, and for description will be the same, and for the region is Middle East Doha, and the subnet range is 10.0.2.0/24. Then click Create. We're done in third steps. Next, we need to create a Cloud NAT. By using Cloud NAT, my VMs remain invisible to the public internet. It prevents external entities from initiating direct connections to your servers, and traffic from the internet can only reach your servers through the My Load Balancer as entry point, which is a fundamental design principle in secure enterprise cloud architecture. To create Cloud NAT, you need to search for Network Services, then select Cloud NAT on your left side panel. I will give it a name, Tony-Cloud-Gateway. Then select Cloud Router by selecting Tony VPC, and for region will be Middle East Doha Central 1. Then click Create Cloud Router, name it Tony Router. For description, will same for subnet ranges. Click Custom, then select VM Subnet. For network service tier, select Premium, and then click Create. Next, we need to create our virtual machines. Search for Compute Engine and click on it. Then create an instance. I will name as XYZ GCP Web Server 1. I will select Middle East Doha region, and for the zone, I will use Middle East Central 1A. Then I need to modify the OS to Ubuntu 22.04 LTS. For the networking tab, add network tag as Web Server 1. For network, select your VPC, and for the subnet, use the dedicated VM subnets. For external IP, you should select none so that there will be no public IP for this VM. For the second server, I will create by myself since it is same process. Only the difference is the name of server. It will be XYZGCP Web Server 1, and server tag will be Web Server 2. Now, as you can see, both of the VM are now created. Now, let's move on to the core of our security architecture, deploying the firewall. First, I'll head over to the search bar to find Compute Engine. From there, we'll start creating our new instance. I'm going to name this one Tony-NVA-Firewall. For the location, I'll select the Middle East, Doha, ME Central 1 region, and simply leave the zone as the default selection. Now notice that I'm enabling IP forwarding here. This is the secret sauce of our setup. It's what allows this specific VM to act as a gateway and pass traffic meant for other destinations. For our first interface, NIC0, I'm selecting the Tony-VPC and specifically attaching it to the firewall subnet. It is absolutely critical here to set the external IP to none. We need to add a second network interface, NIC1. Again, we'll select the Tony-VPC, but this time we'll attach it to the VM subnet. Just like before, make sure to remove the external IP. The strategy here is simple. Internet user requests will enter through NIC0, the firewall will process that traffic based on our security policies, and then the clean traffic will exit through NIC1 to reach our actual VM servers. Finally, we'll click Create. As you can see, our firewall instance is now successfully deployed and ready for the next stage of the lab. But before we continue, I want to stop and explain something important. To make this firewall truly powerful, we need one more critical step, installing Suricata. Think of this as the brain that transforms a simple router into a high-end security appliance. So what is Suricata? Suricata is a high-performance, open-source security engine. While a standard firewall only looks at IP addresses and ports, Suricata actually reads the traffic content. This is how we detect and block SQL injections and malware in real time, providing enterprise-grade protection without the brand name price tag. Under the hood, it's a powerhouse. It handles full intrusion detection, prevention, and network monitoring. Thanks to its multi-threaded architecture, it's incredibly fast. Key features include App ID, signature-based detection, and TLS logging, all while integrating perfectly with modern monitoring tools via EVE-JSON output. The best part? Suricata is completely free. You get zero licensing fees, no vendor lock-in, and massive hardware efficiency. It's professional grade security that scales without the per interface costs of big vendors. I won't deep dive into the configuration today because it deserves its own spotlight. So stay tuned for a dedicated video on that soon. Next, we need to create our firewall rules. Just search for firewall in the console, select it, and click create firewall rule. I'll name this one allow-glclb-ingress and use the same for the description. For the network, select Tony-VPC. Under target tags, we'll enter our VM tags, web-server-1 and web-server-2. For the source, IPv4 ranges, enter 130.211.0.0/22 and 35.191.0.0/16. These are the official Google ranges used for load balancer health checks. Set the protocol to TCP port 80. This policy allows the load balancer to monitor our server's health so it knows where to send the traffic. Now, let's create a rule to allow SSH access. This is what lets us log in to enable web services and upload our HTML code. Click Create Firewall Rule again and name this one allow-SSH for -VM. Again, choose the Tony-VPC. For the target, I'll select all instances in the network since this is just a demo. For the source range, we'll use 35.235.240.0/20. This is the official Google Cloud Identity Aware proxy range, which is required since I'll be using the browser-based SSH option to access the VMs. Finally, check TCP, set the port to 22, then click Create. Now let's deploy our load balancer. First, we need to create an instance group. Let's head back to the console, search for Compute Engine, and scroll down the left panel to find Instance Groups. Click Create Instance Group. I'll name this one Tony-Instance-Group-1. Make sure to select New Unmanaged Instance Group. For the region, choose Middle East, Doha, and specifically Zone Middle East Central 1-A, as that's where all our VMs are located. Select the Tony-VPC and the VM subnet. Now, add both Server 1 and Server 2 to the list, click OK, and then Create. Now let's deploy the load balancer. Search for Network Services and click Create Load Balancer. Choose the application load balancer and hit Next. We'll make this public-facing as it will be our entry point and handle our SSL certificate. For the region, select Global and continue through to the configuration page. In the front-end configuration, we'll name this Tony-Frontend-LB. Select HTTPS as the protocol. For the IP, we need to create a new static address. I'll call it Tony-LB-public-IP and click Reserve. Under Certificates, choose Use Classic Certificates, then create new. I'll name it Tony-SSL-Cert. Select Create Google Managed Certificate and enter the domain I purchased from GoDaddy, xyzcompany99.com. Once that's set, click Create. Next, let's move to Backend Configuration. Click Create Backend Service and name it Tony-Backend-Service. Set the backend type to Instance Group and the protocol to HTTP. Now, we need a health check. I'll name this Tony-Health-Check, setting the protocol to TCP on port 80. And click Create. Back in the service menu, select our instance group, set the port to 80, and hit Create again. We'll stick with the simple host and path routing rules for now. Finally, review everything. Name the load balancer Tony-Load-Balancer and click Create. And there we go. As you can see, our load balancer is officially created. Now, we need to create an A record in our DNS server, which in this case is handled by GoDaddy. First, let's grab the public IP of our load balancer, copy that address, and then we'll head over to the GoDaddy domain settings to create the record. Click on your domain, go to DNS, and then click Add New Record. Select A for the record type. For the name, use the @ symbol, and for the value, simply paste the load balancer's public IP. We'll set the TTL to 1 hour and click Save to update the DNS. What this does is simple. When someone types in xyzcompany99.com, GoDaddy uses this A record to point them to our load balancer's public IP, which then directs the traffic straight into our cloud infrastructure. Now, before we can test everything, we need to enable the web server services on our Ubuntu VMs and deploy the HTML code so our browser has something to display. I've already prepared the scripts for both server 1 and server 2. Feel free to copy these if you're following along with the lab. First, let's head to Compute Engine and select our VM instances. I'll open server 1 and click SSH to log in directly through the browser. Once the terminal is ready, I'll just paste in my setup code and let it run. Now, we'll do the exact same thing for server 2. Open the SSH window, paste the second block of code, and execute it. And just like that, we are all set. Now, it's finally time for the moment of truth. I'll open a new browser tab and head over to xyzcompany99.com. And there it is. The first server is working perfectly. Now, I'm going to hit F5 on my keyboard to refresh the page and trigger the load balancer to hand off the next request to our secondary server. Excellent. As you can see, the secondary server is up and running flawlessly. This confirms that our high availability architecture is properly configured and fully operational. This lab is a total success. Thank you so much for watching and have a great day.